good afternoon, depending on where you're located today. My name is Shilpa Malik, and I work for the Floodplain Management Division at FEMA headquarters. Welcome to today's webinar on how to review a 2D no-rise package. Today's webinar is a pilot webinar, so this is the only offering of this webinar at this time. This is open to all audience. However, it is we are assuming that this is a very technical audience who are well versed with 1D modeling and 1D no-rise analysis. Therefore, the instructors will not be explaining any basic concepts on how to review the no-rise or 1D modeling questions. With that, also this webinar is being recorded today, and the recording and the slide decks will be made available to the participants at a later date. With that, I'd like to introduce our presenters. We have two great presenters today. The first presenter is Sarada Palikivaya, and she has over 21 years of experience with the NFIP and 1D and 2D modeling, and has directed and managed several countywide FEMA flood insurance studies for multiple counties and parishes. She also co-leads Atkins' internal innovations team to identify and implement new technologies in watershed modeling. Our second presenter is Lauren Sester. She is also with Atkins. She's a water resources engineer with 5 years of experience in H&H modeling and floodplain management. Lauren has been a FEMA case analyst for regions 4, 6, and 9, and assists with large-scale map update efforts. She graduated with a bachelor's in ecological engineering from the Ohio State University. With that, I'm going to turn it over to our presenters. Thank you.
Can you all hear me okay?
Yeah, we can hear you.
Okay, thank you. Thank you, Shilpa, for the introduction. Thank you, everyone, for joining me and Lauren today. Our goal today is to simplify the complex technical components of a no-rise package review for 2D modeling, and also complete this webinar within 2 hours as planned, as it is one of the complex topics. With that, I'm going to just give again just a quick bios that Shilpa already gave. My name is Sarada Kalkivaya with 21 years of experience in the NFIP program, and also recently led the 2D floodway development guidance for FEMA. And Lauren is Atkins's eng professional with 5 years of experience, but she's been doing a lot of 2D submittal reviews for the LOMARS and LOMAR reviews. And actually recently she did conducted a workshop related to this specific 2D LOMAR submittals, how to actually submit it. And now this is going to be a topic for her to talk a little bit more about how to actually do the reviews on behalf of any community or a FEMA or anybody. So that's our brief introduction. I know Shilpa gave a little bit of a background about this training, but before we start the training, let's also talk about what we're going to discuss today, who this training is for. Some of our expectations from the audience, you all, is first and foremost that you all understand floodways and no-rise using 1D modeling, and also wanted to apply that concepts to 2D modeling. And this session will focus on current CFR requirements. So this session will provide technical terms that you need to review a no-rise when a 2D model is utilized. And as Shilpa mentioned, but I also wanted to reiterate, this training is going to be ideal for a floodplain administrator or their support team members or any participant of the communities that wants to get a chance to look at the 2D submittals. So, and the topics we're going to cover during this session is the floodway CFR requirements. What is the difference between, are they going to be any different from 1D to 2D? And also discuss a typical or atypical scenarios when a no-rise is required. And also we'll introduce 2D and how it is different from 1D. And at the same time, why are we doing 2D modeling now? And talk a little bit about the advantages and challenges that comes with a 2D model. And that would be the topic that's going to be covered by me for the first hour. And then Lauren will talk a little bit about the types of reviews, which were divided that for ease of use would be the administrative and the technical. And then she's going to go into in depth between a technical review and an administrative review as well. While we're doing this, we wanted to ask a few questions just so that we are, first of all, listening and understanding, and also getting a good idea of what these concepts are. We have 9 total checks, so all those questions will pop up as a poll, and we would like you to answer them, and we'll explain whether what's right or wrong. And also, before we talk a little bit, the later part of the session is an hour worth of detailed reviews. What I wanted to highlight is, because as I mentioned, it's going to have 2 types of reviews. One, administrative, which is meant for a non-engineer, and then another certain content for a technical review, more in-depth review of models, and we'll talk about the 2Ds. But then the idea here is if you're an administrative person and don't have the technical knowledge at this point, but you can follow this step-by-step guidance that we're planning on providing as part of this webinar at a later stage. So you will understand, you'll start learning all the technical jargon that's related to 2D modeling. So before we talk about all the details, I think it is very important to remind yourself the official definition of a floodway. And it is a good idea to just remind yourself about this session because it's a 2-hour session. And the floodway means the channel, it means the channel of a river or adjacent land area that must be reserved to discharge the base flood without increasing more than a designated height. Please note that it includes channel and adjacent land areas. Also note it is designated height, not just 1 foot. As you may be aware, that 1 foot is FEMA's National Flood Insurance Program's minimum standard. So let me explain the floodway concept using the graphic on the slide. We'll start with a 1% annual chance or a 100-year base flood floodplain. And then you assume there will be development that encourages or fills in the adjacent land area towards the channel. And then the encroachment will likely cause a surcharge. A surcharge is increase in water surface. And then that's how the surcharge is calculated, and the floodway is defined when the increase reaches the designated land. And the flood fringe is the area where encroachment, development, and fill is allowed as per the FIP. So keep in mind, surcharge means increase in the base flood elevation. I understand this slide is a bit wordy, but it is the official definition of no rise from 44 CFR section 60.3D3. It states that a community shall prohibit encroachments, including fill, new construction, substantial improvements, and other developments within adapted floodway, unless it has been demonstrated through hydrologic and hydraulic analysis performed to show that proposed encroachment would not result in any increase in flood elevations within the community during the occurrence of a base flood discharge. So that's the requirement. And the NFIP standard for no rise is 1 feet, and it is a minimum standard. And the certification should be signed and sealed by a professional engineer in the state or the territory. So that's the definition of the no rise. And so official definition of a no rise requirement when there is no designated floodway. So when the floodway is not designated on the firm is from 44 CFR section 60.3C10. It states that communities shall prohibit, same terms, prohibit encroachments, including fill, new construction, substantial development, and other developments within zones A1 through 30, which are the old zones, and AE on the community on the firms. Unless, without a designated floodway on the firm, community is responsible to demonstrate that the cumulative effect proposed development along with other existing developments that there will be no increase in water surface elevations more than 1 foot at any given time, since we're still talking about the NFIP regulations here. So here we talked about FEMA minimum requirements of 1 foot surcharge. However, please note that there are requirements from state or local specific regulations regarding no-rise and floodways. For example, state of Minnesota requires that surcharge cannot be more than half a foot instead of 1 feet. Also note, multiple communities prohibit residential structures within the floodway for public safety. So please check state-specific regulations and their impacts to no-rise certification process. Before we talk about no-rise in 2D, basic information that is still applicable from 1D I wanted to highlight here regarding the floodways on the firms or flood insurance studies. For NFIP purposes, model surcharge can be between 0 to 1 feet. And there are few things that I wanted you to be just keep reminding you would be the 1% annual channel floodplain edge would be the boundary, and then 1% annual chance floodplain edge with encroachments, which is the floodway boundary. And then in 1D setting, you would be seeing those cross sections, the cross sections from the 1D models where analysis is complete. So as long as you know those three critical elements on a firm, then you basically get the idea of the three critical information on the firm. So scenarios where no rise is equivalent, it doesn't mean whether it is either for 1D or 2D, the scenarios are the same. The typical scenarios are structures impacting either or built near or close to an SFHA, that's a special flood hazard areas, which includes building a multi-family apartment complex. A scenario could be a resident is proposing a deck close to a floodway, or a commercial development to build a shopping center. So any of these are typical scenarios you would get a request to get the reviews. Please note that these common in all these scenarios is all the proposed development is within designated floodway or very close to it. So those are the typical scenarios, but there are going to be a lot of atypical scenarios, which means you don't get to see more often, but they are there and there is a chance that you may need to review it. So the first one would be a proposed development in the conveyance shadow of an existing building. So conveyance shadow means an area upstream or downstream of an existing obstruction to the flood flows. So it could happen, somebody already had an existing structure and they're trying to add additional structure or a building within that. So you can see on the graphic how that additional structures, you still need to look into it. Or a bridge or any other infrastructure, including a culvert, a pipeline, or utility line that spans the floodway, extending down into the channel and the overbank areas within the floodway. And then there are ongoing activities such as somebody is mining or dredging or disposing of that dredged materials within the floodway. So these are not typical, but then there's a chance that this is all happening within your community. So with that basic information, let's do a quick knowledge check. And Keith, are you ready to release the poll? So here is, I'm going to pull the poll here, or you can see it. So yeah, this table provides water surface elevations for both existing conditions and proposed conditions, and it's calculated near area of interest. Please observe the difference column in the table. Do you think the data provided in this data supports a no-rise? That means they don't have to get a no-rise certificate. So we got 30% participation, so it's going up. So we'll give a few minutes or maybe a minute or so. Okay. 75% participation, which is very good. Hopefully this is a very simple answer. Everybody gets it right. Okay, it's slowing down. Maybe so everybody's okay. We can end the poll. Okay. So the answer is no. The correct answer is no. A rise of 0.08 feet is still a rise. When you round up the increase to, it is 0.1 feet. And so the definition of no rise requires that there will be absolutely no increase in water surface elevation within the floodway. So whoever said yes, so that's the answer. And whoever said no, that means you already got the fundamentals of the floodways. So the next question. Okay. So a developer is planning to dredge in the area contained within the property boundary on the right. Do they need to get a no-rise certificate? So the developer is planning to dredge in the area within the property boundary. It's very close to the floodway, 1% annual chance and 0.2% annual chance. So do they need to get a no-rise? That's 80% participation. I'm glad that everybody is actively participating after lunch. Okay, I think it's slowed down. So I will reveal the answer. Maybe you need to end the poll. So the answer is no. Yes, the correct answer is no, since the dredging is outside the official floodway limits. However, we can still request the data to show there is no impacts beyond NFIP regulations. So please keep that in mind. Depending on your own regulations, you can still ask additional analysis or additional data so that there is no other impacts beyond NFIP regulations. So with that, we can close the poll. Okay, so now let's discuss no-rise definitions in 2D compared to 1D. The reason we're going back between 1D and 2D is since the expectation of this webinar is that you already have some familiarity with 1D. So that's why we wanted to make sure that your the 2D, is it different? If there is a major difference, we're going to talk about it. So there is actually no difference in no-rise definition or requirements for 1D and 2D modeling, except how and where the water surface elevations are calculated or evaluated is the difference. So that means how the water surface elevations are calculated in 1D and 2D is different based on the methodology. And we're not going to talk about how it is calculated. But then we will talk a little bit about where the water surface elevations are calculated or evaluated on the flood insurance rate maps or even in the flood insurance studies. When a 2D analysis is completed, surcharge is evaluated at evaluation lines. This is the new term. We will keep repeating this term more. And so the one thing that if you want to get out of this webinar would be learning the term evaluation lines for 2D rather than a lettered cross sections. Please note that in the 2D, surcharge can be negative. And also notice, as you see on the right side graphic here, BFEs are not straight lines anymore because the water surface elevations, or those lines are is a contour line where the water surface elevation is the same. So it won't be straight line anymore as 1D cross sections or 1D BFEs. So that's the main difference. But the definition is not different from 1D to 2D. So before we talk about introducing the 2D, I wanted to start with, again, comparing between a 1D and a 2D. So in 1D, water surface elevations are calculated along a line known as cross sections. So like the red line on this graphic. In 2D, the water surface elevations are calculated everywhere within the mesh or a surface, like the red polygons in the right graphic. In 2D modeling, you will hear a lot about the term mesh in general, and I know Lauren is going to go in more detail, and I'll explain what that mesh really means in coming slides as well. So let me now introduce a little bit more into the 2D modeling while still providing references to 1D modeling. In 2D models, cross sections are replaced with a series of points that are connected to form a grid or a mesh rather than a straight line. And then the volume of water is routed or calculated through the mesh that calculates the flow in multiple directions. Each mesh is comprised of a grid. Either it could be a 10 by 10, like 10 feet by 10 feet, that each represents an average elevation within the grid. Please note, the grid sizes can vary from a 10 foot by 10 foot to a 1,000 foot by 1,000 foot, or in between. Or even the grids can be different from within the same model. When it's close to the channel, it could be more detailed. And even if it is away from the channel or the floodplains, it could be more coarse, that is much, much bigger grid sizes. But please note, in general, finer the grid size is, the model takes longer to compute the results. So that's the balance that we always, the modelers or the engineers, needs to make a decision about. Either do we make the models run longer, faster, efficient, or more accurate by just adding more details to the grid. It is important to note that per 44 CFR 65.6A and A, unless the basis of the request, especially for a LOMARS or a LOMAS, is using an alternative hydraulic method, the analysis must use the same hydraulic computer model used to develop the BFEs in the effective firm. Therefore, it is best to request approval from FEMA before submitting an MT2 request that is not based on the effective hydraulic model. The reason we wanted to highlight that point here is, especially if you see there is a 1D model is the effective model, and it's better to stick with that, with the 1D model, unless you see a valid reason why you need to go with a 2D model. And if you're planning on using a 2D model, it's better to get the approvals ahead of time with FEMA. So with that, we talked about a little bit about the comparisons. And then why are we using 2D modeling, right? Because most of the current FEMA studies are using 1D models, but then why are we started using 2D modelings now? In general, 2D simulations provide more accurate hydraulic results when flow paths are complex and can have different paths based on an event. The 2D models also provide additional information such as when flood water will arrive, that means the timing of the flood wave, if it is important, and what will be the speed of the water, that means the velocity of the flood water. And the 2D models gives you that additional information, that additional details in the models, and sometimes it's much more important than just knowing the water surface elevation or a BFE. It also helps to mimic the unsteady nature because it's not a steady, floods are not steady. So it also helps to mimic the unsteady nature of a flood event, like you are seeing on the graphic below. And also to explain the flood hazard using the cool animations like this, to show them how the flood water moves within the watershed. Especially like an engineer like me, now I have a tool like this to explain the complex engineering analysis visually. By providing this additional data points improves the stakeholder engagement for our flood studies. So that's one of the main reasons that we are moving towards that 2D modeling. Also, here is another cool graphic that I wanted to explain why we wanted to use 2D models in the future would be, please observe those black lines on both the graphics. Both of them actually represent, cross sections in a 1D scenario. So the left one shows the 1D cross sections are contained when then there is a low or a moderate flow. Think about it, a 5-year or a 10-year recurrence event is modeled. However, in the same model, when a high flow event, think like a 100-year or a 500-year event is modeled, where it has multiple flow directions and it has, it's coming out of the channel and going into the floodplains, then 1D cross sections are overwhelmed. You're not able to actually analyze it properly. So based on this particular example, main benefits of 2D or if we actually use a 2D model, then there is no need to redraw those 1D cross sections or extend them to capture those high flows. And also, you don't need to define the flow paths because for 1D, you are making an assumption that the channel, the flow, everything else is constant along that black line. But which is, you don't have to make that assumption when you are using a 2D model. And also, you don't need to actually estimate how much of the flow is going to overflow into the floodplains. And so that's the advantage of the 2D. And so, like I already mentioned, in addition to these above technical advantages, these animations that I'm showing on the screen is very helpful in communicating the flood dynamics better, and also communicate that flood patterns actually change based on a particular event. So that's actually helps really well for education and the communication of the and stakeholder engagement purposes. So far, we talked about the advantages of 2D models, and now we'll discuss about the model outputs, which is a very important output. One of the main important outputs is the velocity, or what is the speed of the water of the flood wave. Currently, like average velocity information is available only in the floodway data tables at cross sections. See the slide on the left, which shows that velocity throughout the channel over banks varies along with the depth. Velocity is about 5 feet per second, should be evaluated with more care because it can cause more damage and it affects the safety, public safety. So on the slide right, which is a 2-hour time-lapse video at the same location, on the right, which shows the impact of water with high velocities. You can see, I know it's in a time lapse when people are just walking around, no flood waters, but then the flood waters with the high velocities, it's sweeping all of those cars, and so you can see the damages. So, which is important to know if that happens at a particular location, the velocity information is critical to know. So, those are the outputs that are easily available from a 2D modeling. So other advantages of 2D modeling that are typically beyond our current topic of discussion, but however, I want you to be aware to understand the big picture of the NFIP program in general. Traditionally, in the flood insurance studies, the models are updated or created stream by stream or community-based approach using 1D model. With the 2D based modeling framework, it is going to be a watershed wide, not just the stream by stream. It's going to be analysis going to be watershed wide. And the watershed based approach allows us to include both rainfall, which is the pluvial, and the riverine, which is the fluvial flood hazard at the same time. This approach also supports one model per watershed and will also include all the streams so that the cumulative effect of the development can be evaluated as intended. So it's not about the one community, it is about the entire watershed. So that's the main reason why we are seeing more of these 2D models and a watershed approaches. And I think this is the first, we are at the cusp of changing or developing more models from the 1D to the 2D. So with that, I wanted to take a because we had some basic introduction about the 2D modeling, let's see if you're able to answer some simple examples where the 2D modeling is necessary compared to a 1D. Thank you, Keith. Hope you can see the question. So if the requester is proposing an aerial sewer crossing, just shown on these pictures, the effective model is 1D. Is there an ideal scenario for a 2D model to be utilized? We just talked about it, so hopefully you all get this right answer. I'm so happy to see you all at the active participation. So the requester is proposing an aerial sewer crossing. It's an elevated structure. And the effective model is 1D. Is this an ideal scenario for a 2D model to be utilized? I think the poll is slowed down. So can you end the poll? And I can show the answer. Answer is no. Because first of all, the effective is 1D model. So it is recommended, and we just saw the CFR requirements to use the same approach unless a better approach and get an approvals ahead of time to use 2D. Secondly, the 2D modeling for this scenario is not even applicable, as this is, like I said, is a horizontal aerial sewer crossing, and it is not impacting the flow pattern. So we can stick with the 1D here. We don't need to go complicated 2D modelings in this scenario. Okay. With that, I will go to the next point. So again, since we're still talking about the introductions and comparing with the 1D and 2D, since we talked about the modeling side, how different is going to be the flood insurance rate maps when you compare between a 1D and 2D. So here is an example how different a 1D and 2D model can create the floodplain mapping on the final firm. In this example, the flooding source is analyzed using both 1D and 2D, just for to show the comparisons. And then if you can see on the right side, which has a 2D model, it shows more detailed flood boundaries along with a separate floodway designation, which you can do it with the 2D models. Even though if you're comparing the BFEs, they're not too different. So the water surface elevations are not different, but the detail of the floodplain is much more detailed in this. So that's what you will see. So with that, again, wanted to talk a little bit more about the evaluation lines, as I introduced in the beginning, as the major difference between 1D and 2D is the evaluation lines. Now we'll discuss a little bit more detail. So the easy way to understand them, or the evaluation lines, is 1D cross sections, but contour to represent single water surface elevation. Like in 1D, evaluation lines are set at critical locations and will be shown on the floodway data tables. And also please note that the firm will have both contoured BFE lines, as shown on this graphic on the right side, and evaluation lines when floodway is created using 2D. So when you look at a firm and when you see these BFEs or looking like that contour lines, you can get an idea that this area has a 2D model rather than a 1D model. So you can easily identify whether it is using a 1D or a 2D. So if you see a wiggly BFE line, most of the time, most probably it is a 2D, 99%. And then we talked about all of the good things about 3D models. However, every time, right, there's always good thing. There's always some common challenges associated with a new approach. So the common challenges are compared to 1D, the floodways are wider but more accurate. That's why I said typically, it's not always the case, but they are more accurate. The main reason for being more what is the floodways are analyzed based on the time, like we talked about it before, and the accounts for all the water that accumulates in that location. So even if the water traveling from a different location, it's coming slowly, but then it accumulates in this location. So typically they're going to be much more volume of water. That's why typically the 2D floodways are a little bit wider. Also, 2D models typically takes hours to run the simulations rather than seconds or minutes when compared to 1D. Also, building 2D models or creating these 2D models requires more technical expertise, especially when you want more accurate results. Creating initial models are not, it's easy to create. The softwares are very helpful for that. But when you start adding more detail into the 2D models, you need a technical expertise. Sometimes the scenarios where no rise cannot be achieved in the 2D setting, especially in 2D. In that situations, no rise permit should not be approved. For the same location, sometimes a no rise is possible when a 1D model is used, but sometimes if a 2D model is used and you cannot generate a no rise, because it's especially sometimes because there is a change in the methodology and you compare with an effective or additional details in the modeling, or sometimes it's about just the software that is used for the analysis. So sometimes you cannot get a no rise, even though you might get no rise in a 1D at the same location. So for projects with a raise, a CLOMAR is required based on 44 CFR 65.12 and 60.3 D4. And please reach out to a FEMA regional office or state NFIP coordinator or a reputed engineering firm if you need support with a CLOMAR or especially when you see a raise and need to provide some additional guidance to the stakeholder or a developer. So these are the additional resources, and you need to keep in mind raise is possible, not like 1D. So keep in mind that CLOMAR is required in those cases. As I mentioned, I got this slide back in here, and Lauren will talk a lot more, provide a lot more details about these two types of reviews, which is one is the administrative, and it's meant for non-engineers. And she will go into detail about what is it, what does an administrative review mean, what is the data that should be available and submitted, are you noticing any violations, or are there any ongoing projects in the same area? So all of these things that she's going to talk about it and should be part of your administrative review. So the administrative review doesn't go into the technical review, which is what the technical review is for, which is mainly for any engineers and anybody, any FEMA regional engineer or any other staff members that has more information or know or interested in knowing more about the technical side of the model itself. And so the technical review go into the more details about the models, whether it is modeled accurately or the model outputs from the actual model itself versus a flood insurance rate map or FIS report, or is that everything is provided, or is it coming from the same model? So that would be the technical review that Lauren is going to go into detail in the next in the hour. Before we move forward with how to review the two-raise submittal, packaging the whole entire thing in a detail, here is a simple workflow. And I will go in a little bit in detail about all of these steps. And this chart will also be provided as an additional handout, so you can actually look into more depth, because I know there's a lot of words on this particular graph, but I wanted to show a couple of them in detail. So for example, did all the required data submitted by the requester? If the answer is no, then request missing information. If not, start the administrative or technical review. So Lauren will talk about it. What is the required data, right? When you get the submittal. And then same thing, Are you comfortable completing a technical review by yourself, or do you need support from a team member or someone else? Or you can also request to submit a CLOMAR if you are not comfortable doing that technical review by yourself. If you have experience or technical background, please proceed with the technical review as well. And if you identify technical challenges with the modeling data, whether it is you see a raise in the water surface elevation, then you can return to the requester, asking them, hey, mitigate the raise because I see a raise. Like our first question, 0.008 is a raise. So if you see that, then you can say, hey, mitigate the raise. I want that raise to be no rise, and request them to resubmit. Or you can ask them to submit a CLOMA. If there are no technical challenges, you can use the steps provided in this webinar to complete your technical review. So this workflow is provided just to give that it's just a simple yes or no questions, and then you can go ahead and use it moving forward with the webinar. Here are some available options for you if you need further technical assistance. I think I did mention it before. Reach out to your FEMA regional offices or state NFIP coordinators, or look for a potential hire to hire an engineer to help you with the no-rise. Or during the administrative review, if you determine additional technical expertise is needed, a CLOMAR can be requested or can be required. So these are your other technical assistance. If you are not 100% sure whether you got all the data necessary, or your no rise is clear, or if the data itself feels like more complicated, then you could use some of these potential technical assistances. With that, I want to just do one more knowledge check. We'll see if you are able to answer this one. Okay, I'm going to move the poll to the right. If the requester is proposing a residential home in the 0.2 annual chance, which is the 500-year floodplain as shown to the right, is a no-rise required? I'm really happy that there is very, very active participation. 80% within 30 seconds. It's a good one. Okay. I think most of, are you getting it? Okay, it's slowed down. So I will show the answer. Okay, so the answer is no. 83% are right. The reason being, the requirements of a no-rise are only applicable within the floodway or the 100-year floodplain. So again, based on the NFIP regulations, unless you have another requirement, you can ask, but based on the NFIP requirements, yes, if they are within the 500-year, no-rise certification is not required. So with that, we have successfully completed the first part of this webinar that provided you basics of 2D modeling, why we use 2D modeling, and let's take a maybe 5-minute break while Lauren gets ready to discuss the two types of reviews that I introduced a little bit, and then we'll start back in 5 minutes. Sorry. I'm looking at a couple of questions on the Q&A session while we're waiting. I'll stop sharing my screen. Lauren, you can go ahead and share your screen meanwhile.
All right, it is 55 after, so we will go ahead and get started with the second half. So as mentioned, we will first really start going through the review walkthrough from an administrative perspective. And before we do that, we also want to mention that we will be throwing an additional handout in the chat. So this will hopefully serve as an additional guidance for you when you begin the review process. It's not an official checklist, but it will serve as a helping hand to remind you of the checks that are required through this process. And as you can see, it has different tabs at the bottom, depending on the type of review you plan on doing. So as we go into what those administrative review steps actually look like, we'd first want to make sure that all of our items are actually included in the package that we receive. We want to review that their no rice package is actually certified. We want to read through the report, fully understand what they are planning and why, and we want to download the effective data so that way we can compare it against what they're submitting to us. And then 5, we will verify that everything they submitted is actually complete and then accurate against those other review items. So step 1, again, just checking to ensure that we actually have all of those required documents. So this is almost the same list as you would see with a 1D submittal, but it will be slightly smaller because, as mentioned here, a lot of times your annotated floodway data table, certain hydraulic models, and your annotated flood profile will not be applicable in a lot of scenarios. So just familiarize yourself with the requirements. They're all available on FEMA.gov, and just making sure that they are all included in that submittal. And then as part of that package, the first item we really want to review in depth is the no rice certification. So the image here on the right will be commonly seen in your packages, as this is the example certification that FEMA includes in their instructions and details on their website. So the main key to reviewing the certification is ensuring that it's signed and sealed by a registered professional engineer, and as it states that the community has signed it, whether that's you as the FPA signing it, or you're ensuring that the community has already done so. If your area does not have something like this, please make sure you're reaching out to your state NFIP coordinator for assistance. Sometimes this may actually be embedded in the floodplain development permit application process. And then step 3 is going to be reviewing that report. It really needs to be dated, titled, and signed by a professional engineer as well. And it really should include any project background, ongoing studies, why they're modeling the way they are and making the choices that they're making, as well as a discussion of their proposed results and outputs. So after reading a report, as the reviewer, you should be fully able to understand the what, why, and how of the choices they're making. And if we don't understand that at the end of the report, then it's a really good indication that we're going to have to follow up with them, or we need additional data. And after we've reviewed their certification, we want to go to the FEMA Map Service Center and download the effective data. And there may be additional ways for you to get effective data locally. However, this is the most easy and universal way to gather that information. You can really do a quick Google search and type in the FEMA Map Service Center, and the first thing that will come up usually is this site, but we also have the link provided here. And then we'll follow through the steps. So first, you just need to search all products, enter your local jurisdiction, search within your jurisdiction, and then go through the effective products folder. So this products folder here will include your firm panels, your FIS report, and maybe even a digital database if they have it. And then when we have that data, we want to start comparing it against their submittal. So we're really looking to double check that they used the latest effective data, their submission aligns with what you're seeing in the effective data, and we also want to make sure that there are no ongoing LOMAX or studies being done within the same area that may impact their project that hasn't been considered. And the ongoing LOMAX can also be found in the effective products folder, so you can double check and make sure that you're comfortable with that. And then we also, best practice is really keeping all of these documents open and continuously referring back to them as we continue through this review and we're looking through all remaining data. And then step 5 is just going to be verifying that all of the rest of the items within that package are complete and compare all of those to the proposed changes and the effective data. So we'll be going to look at the models, topographic work map, annotated firm, and all of the FIS attachments. So bear with me while we go through these, where we'll be checking the 1% and 0.2% annual chance floodplains, floodway widths, delineations, BFEs, and evaluation lines. As we're going through these, you want to keep asking yourself, how do they compare to the effective? Are these changes logical? Do they make sense with the contours? And really just some base checks like that as we move along. So the first thing we'll touch on are those hydraulic models that ideally should be included. First, you'll want to verify that they have an effective base model. So this is going to be the model exactly as they received it from FEMA in the same software, even if it was a PDF, because there still are some HEC2 floating around. And then we'll have the duplicate effective model. So this would be resulting from the effective model with no changes made being run on their computer. And then it would move to the corrected effective model, which will also represent those effective conditions as they were when the effective model was made, but it's going to now include any corrections that needed made to that effective model, as well as updating the modeling version to whatever software they will be using moving forward through their process. It also is important to note that they won't always need a duplicate effective or corrected effective model. If there's no digital effective model, they will not require a duplicate effective. And then if the effective model runs with no errors and everything is modeled correctly and in the correct software version, then they won't need to create a corrected effective version. And then they would move to the existing conditions model. So this is where you start taking the model forward and represent conditions as they are in the ground now, really including any changes that have occurred within that project area they're working in since the effective model was made. Then they'll move to their proposed conditions model, which is really where they add in what they'd like to change in the plans that they have. So a quick reminders as you're reviewing the hydraulic models is you want to ensure that all model versions and plans are reviewed. So you want to be putting the same level of effort into reviewing the proposed conditions as you are the existing conditions, because every iteration of that model is an important part of the analysis and an important part of the review. You also want to be mindful of any violations that may have been caused by someone else previously adding man-made changes within the project area that maybe weren't taken through the appropriate steps. This is very uncommon, but if you do see it happen, you want to make sure that you're documenting that and aware of it. And then you also want to just be mindful of terminology and mindful of what they are actually deeming certain things are. So technically, pre-project could mean both existing conditions or corrected effective conditions, and post-project is typically used to describe proposed conditions or actual post-project as-built conditions. So these terms are used fairly interchangeably. So when they're using these terms either in their topographic work maps or their narratives, we want to make sure that we as reviewers understand exactly what part of the process they're referring to when they say pre-project or post-project. Otherwise, we might be reviewing something that is not actually the correct iteration. Okay, and then we will go to reviewing that topographic work map. So the goal with the topographic work map is really to visually compare the changes that they're making to the effective maps and then get a draft of what they're proposing those new mapping and BFEs will be. So this will require them to include all of the effective mapping in addition to proposed mapping. They need to make sure they're including their proposed BFE lines, any project modifications, evaluation lines, contours, and by default, they always need to have a scale, a clear legend, and most importantly, this is very commonly missed, is that it needs to be certified by a professional engineer. And that's one of the key differences when we look at our annotated firm. It does not need to be signed and sealed. and it's going to be at the scale of the firm itself. So it's very similar to the topographic work map, but it's only going to include the proposed floodplain and floodway delineations on top of that effective firm, and then they'll add in their BFE lines, evaluation lines, and again, add a legend for those new additions. And then, as we mentioned, we want our evaluation lines on both the firm and the topographic work map, and these are going to be, as mentioned, really your new 1D cross sections. So these are what are now referred to as our lettered cross sections in all of these attachments, our floodway data tables, etc. So these will be represented along with BFE lines. They do not replace BFE lines. Just as you would have in a 1D scenario, you have your regular BFE lines throughout, and then your lettered evaluation line. So should they need to submit a floodway data table, this is an example of your typical annotated floodway data table. Again, your lettered cross sections on the left are now your evaluation lines. And what really makes this an annotated versus an effective floodway data table is this box here that highlights their revised data and includes any changes that they are proposing. Similarly, if they need a profile, we now have our lettered cross sections, which are evaluation lines. And again, what makes this annotated is they have a box and they have a revision call out. So now we'll do a quick knowledge check. So looking at this example here, can you tell if they submitted a complete topographic work map? Give you guys just a minute longer on this one since it's fairly visual. All right, Keith, if you want to go ahead and close that out. Okay, so no, this is not a complete topographic work map. We are first and foremost missing any certification here. There's no stamp, no signature on this work map. They also don't actually properly label what their proposed floodplain and floodway are supposed to be. So based on this, they do label their effective firm data, so we could infer that this is the proposed. However, it's not up to the reviewer to make any type of inference because we don't want to make an assumption and then move forward based on that assumption. So we would ask for clarification on that as well. All right, so now we're going to go through the second portion of the review walkthrough and get a lot more detailed and technical. So if you're not looking to get too into 2D, this is a really great stopping point. If you are interested, then we will be going through these technical review steps. So first, we're going to validate that the modeling software is appropriate. We're going to validate the proposed delineations are done accurately, review their floodway surcharges, validate that there is indeed no rise, and then validate that the model itself is technically sound. And I really want to mention that technically these steps could be done in whatever order you'd like, but we are going to start today with the least technical to the most technical, just as a reference for you guys. If it does begin to get a little too involved, we're going to get a little more in depth as we move forward. So step one is going to address what modeling software is out there and what is right for you. So there are multiple software that are approved by FEMA to utilize as part of flood insurance studies, and they can all be found at this link here. For today's purpose, however, we're going to be solely focusing on HECRAS because it is the most common and it's a free software, so it's really what we see a lot. And the other software you might see more commonly are Flow2D and XP Swim, but they're a little more complicated and a little more experience is required. So you don't have to know all of these software as we move forward today, but these are what you'll commonly see for reference. And then step 2 will be reviewing your floodplain extents in a 2D situation. So with 2D mapping, a lot more so than 1D, we see that the requester will submit a raw model output that hasn't necessarily been quote unquote cleaned or finalized. So you can see in the example here that because a 2D model is a much larger mesh domain, we may see flows that are outside of our main stem sitting in a low terrain but completely disconnected from our main stem. We want to make sure that they're not proposing the final floodplain delineations include any disconnected flow. We also want to make sure that they're not including areas of very minimal depth. So a common way that they will clean this up and check this is to look at depth times velocity. When we review their depth times velocity, we can see not only where flow is sitting, but where it's actively moving. And those two components give us a really great idea of where their main floodplain is. Additionally, if you're reading through their narrative and they do not explain their process for how they cleaned and finalized, it's usually a fairly good indication that they didn't take that effort and that the floodplains you're looking at are likely not finalized. We also want to make sure that what they're proposing in all of their mapping actually matches the model and that they didn't maybe over clean or under clean. Then we'll check if they tie in and did they actually map all of the recurrence intervals that we see on the effective firm. So as part of that mapping or graphical tie-in check, we want to make sure that they are within 10% of the effective widths. So that goes for both the 1%, 0.2%, and the floodway widths. So if we're looking at this example here, the blue is their proposed floodplain and the pink is the effective floodplain, apologies. And we can see that this width is much greater than 10% different. But we logically can look at this and know that at this single location, based on the contours that they provided, the floodplain would not respond this way. So that is what we would be checking for. And then when it comes to reviewing the floodway in a 2D scenario, we'll also be looking for rapid changes in width. We really don't want to see a floodway suddenly go from 10 feet to 100 feet wide. And we want to make sure that they're using and showing continuous encroachments, that they're smoothing appropriately, and we want to make sure that they're also delineating with what is aligning to the model itself. So just as we would with the other floodplains. And then we also need to go a little more in depth and also calculate their actual surcharges and ensure that they're not greater than a foot. So to check that surcharge in a 2D rather than a 1D, we first are going to need to contour our 1% annual chance water surface elevation raster. So this can be done in GIS, in RasMapper, or other similar services. But we then take this single water surface elevation contour line and calculate at each individual cell along that line what the surcharge is. You then take those individual cell surcharges and you average them along that line to get the overall value. Once you've done step 2, you can then check that the average along that line you just calculated is between 0 to 1 foot. You then need to check that any cell with an insurable structure also has a surcharge within 0 to 1 foot. And finally, you need to make sure that all cells have surcharges between -0.5 to 1.5 feet. And again, this does seem a little confusing, especially if you're familiar with the surcharge calculations in a 1D scenario, but all of this is available through the FEMA guidance. And then step 4, we're going to create an evaluation line summary table and evaluate if there is actually a rise. So ideally, the requester will have submitted a table similar to this, but as a reviewer, you have to independently verify the numbers and results. So we're going to be looking at proposed minus existing, proposed minus effective, and this will be for both 1% annual chance and the floodway. So as mentioned, and I think some of the Q&A, we will be looking at this to 2 decimals, and we want to make sure that every evaluation line that they're submitting ideally is 0.00. All right, now for another quick knowledge check. Would we sign off on these proposed floodplain delineations and BFE lines based on looking at this topographic work map? All right, quite a few of you answered. Quite split on this one. All right, Keith, you can go ahead and turn it off. But about 40% of you have said yes, and about 60% have said no. And the correct answer is no. So there are actually quite a few things I'm going to point out with this. The first being that we have a disconnected floodplain here. So if they are proposing that this is their final floodplain delineation, we would not expect to see all of these isolated areas of flow, and along with these isolated BFE lines that we see. Hopefully you can see they're fairly small, but these light blue lines out here. We will not accept all of these discontinuous BFE lines. Additionally, there are several centerline issues, and this is really just somewhat unrelated, but is really key when reviewing topographic work maps. So if you see their contours here in the terrain, we can see exactly where the stream goes, but it is not where their stream center line is going. And that's really important when they are making these calculations. And then additionally, we have gaps in the floodplain. And now this is going to be community specific. It's going to depend on island standards in your region, but typically when it is a floodplain gap this small and it's a floodplain gap that was previously in the effective, we would not expect to see this hole. So great job for the 65% of you that said no. All right, so now we will really get into step 5, which is going to be all about that model and how to review that model. So first thing I really want to mention here is just make sure that whatever software version you're using is the exact same software version that they are using. And that's true for HEC-RAS, Flow2D, or whatever software you might use. So now that you are assuming you have a plan, it's run, you want to just recall that in HEC-RAS, when we are reviewing a return period, every return period is going to consist of this unsteady flow analysis plan, and it's going to consist of the geometry, which is this green, and then your unsteady flow file, which is this blue. So this is the geometry within the project area and the flow you're putting into that project area, and then together you will run your analysis for that return period. So assuming that's been done, you're starting to run your model, you have the results. There's a lot that goes into the final technical review, so we're not going to get into all of it today, but we are going to touch on these key topics so you have a frame of reference as you begin your review. So first, we'll really touch on the boundary condition. It is how water will enter and exit the system. So we have inflows, whether they be fluvial or pluvial, and then we have outflows. And then with these, we can either place them internally within our mesh or externally outside of that mesh. So you draw your line at the location that flow is either coming or leaving. So this blue line here would be their external boundary condition. And then that line, if it is an inflow, it's going to be given a discharge or precipitation value. And if it's an outflow, it's going to be given a slope as flow leaves the system. So we're not going to get into the in-depth hydrology calculations that consist of really all of the input that goes into the boundary conditions, but that does need to happen in a technical review. We're just going to talk about the hydraulic side of it, which is the placement of it and making sure that we go through the common problems. So some of the things we frequently see are that not all inflows are accounted for. So with our 2D mesh, you have a very large study area. You're really likely going to have a main stem with several tributaries coming in. And they have to model all of those tributary inflows, and if they're not, then their narrative needs to very explicitly explain the thought process for that. We also commonly see, that the boundary conditions are drawn too long. So in this situation here, if we're looking at the model and they're trying to add flow for this stream, but their boundary condition is this entire checked line, what they're doing is actually flooding the overbanks. So that would be a really good indication for us that it's an incorrect placement. And then we would also flag it if hydrographs are not smoothed. So if we are seeing that the peak of a hydrograph is not really following more of that smooth kind of bell curve look, but it's actually jagged or has a sudden drop in it, we would be flagging that. And then with our mesh boundaries, we first want to make sure that the mesh boundary itself includes the entire study area. So if they are trying to analyze an entire development area, we need to have every inch of that development within the mesh. And ideally, the mesh needs to extend past it so we can ensure that there's no resulting changes either up or downstream of that. And then we also want to make sure that there's no flow ponding against the boundary. So in the example we see here, the red lines are those boundary conditions we just talked about. And because the flow is ponding against this, there's a boundary condition line, this flow is allowed to leave the system. So we are happy with how this looks. However, if we saw some of this flow ponding against this mesh boundary, there is no red boundary condition line. So flow would not be able to leave the system. It would essentially crash against that edge and pond, creating a falsely increased water surface elevation and depth. And then we have mesh refinement. So I'm pretty sure someone in the chat actually asked what cell size would be recommended in a certain situation. And really there is no standard guidance for that. It depends on the software. It depends on what you're representing. But we need to make sure that the cell sizes are small enough to capture all features and proposed changes. So some examples of those topographic features are like levees, dams, things along those lines. And then with het graphs, there are two main ways to refine your mesh, and those are break lines and refinement regions. And now we're not going to go into the detail of those, but I will explain why we need them. So if we're looking within this red circle and we are trying to evaluate the results within this portion of the stream, what happens is that within this cell, all of the elevations are averaged. So that means that our very low stream elevation against our higher overbank elevation is averaged into a single calculation. And this is okay, but a better representation would be smaller grid cells. So now within this cell, it's mostly going to be stream elevation, but we still do have some overbank elevation that's going to somewhat falsely increase the elevation within our stream. So the best representation would be to add a refinement region. So this is essentially going to give a much smaller grid within the stream, and now you're not falsely averaging that, and you're really solidifying the elevation within that stream. Okay, so now land use value and Manning's N. So with a 2D model, you now add the Manning's N value as a raster or a grid, and it's going to cover the entire model area. So when we review the land use, we need to check that they added it correctly, meaning it's showing up, there's no errors. And then we need to check that it's showing up at the correct location and that the values are correct. So what this looks like in practice is in HEC-RAS, you will at least get this pop-up. You can check in RASmapper, GIS, whatever software is available for you, but a raster should be able to load. In each of these colors is going to represent a different Manning's N value. And then you can add your aerial imagery. I always prefer to kind of add a translucent grid so you can see through and see what the aerial imagery is underneath. And you can kind of see here that this might not actually be a great example because you would say this aerial imagery is almost the same as this aerial imagery, but we have two colors. So then we want to look at why that is and is the value they're assigning it accurate. So I clicked on this blue and I get a Manning's N of 0.035. And for this blue, we have kind of a cropland, a field. We would say, okay, for that makes sense. And you would have to do that then for every color and every location where there is a color change. And then we'll also want to look at the velocity, but more specifically, any hot spots that we see in the velocity. They're a really good indication of a modeling instability. So I want to first note that velocity should vary in all directions along the reach. It's going to be faster in the main part of the reach and then slower along the outskirts of the floodplain. So you want to just kind of do a gut check and make sure that velocities are reasonable and either their proposed project isn't causing erosion or maybe checking that there is a high velocity indicating that modeling error. So this is an actual example. And we can see here that the velocity at this location is almost 2,000 feet per second. And a quick gut check, we automatically know that that is disaster, hurricane, maybe even higher than hurricane levels. So it would indicate that there's something going on here, and it could be due to either a mesh size issue, maybe structure isn't entered correctly, so flow isn't able to really go through that road like it's supposed to, or maybe the time step needs adjusted. And a key here is it's not really on us as reviewers to figure out why these certain issues are arising, but it's also good to have an understanding of what you're looking at and really gain insight as to why this might be happening, and we just don't really have to provide them suggestions for resolving it. We also want to do a very similar check with the water surface elevation. It should be a large scale review for this one. We're not going to get into actual values. It's a larger check just to make sure that water surface elevation is decreasing as it moves downstream, as it should, and that it's doing so smoothly. We don't want to see sharp drops in water surface elevation, and if we do see those issues, it could be due to a structure, again, that's maybe not modeled correctly, or a topographic feature in the mesh that wasn't represented enough in the cell size. So in this example, we are okay with it. It goes from hot pink to lime green fairly smoothly. And then one of the quickest checks you can do to see if the model is off to a good start is to check out that computation log. So you can find it in the unsteady flow analysis under options, and then view computation log file. And then you will get kind of a notepad that pops up, and you'll want to check the percent error. We want to make sure that it's smaller than 2%, but the smaller the percent error, the more stable the model is. And then very similarly, we will look at the runtime messages. So also under options, view runtime messages, and then you can make sure that the model actually has finished, how long the complete process took. This is also especially important if you want to run the model yourself as the reviewer, because 2D models can take, 6 hours is a fairly short one, to be honest. You might have a model that they ran and it took 30 hours. So you might want to look at that and check that out before you plan on running it yourself. And you can also get a quick look at any errors that pop up. And with that, we will move into another quick knowledge check. So, let me Is the outflow boundary condition and mesh acceptable looking at this example? You guys are answering very fast on this one. Good job, guys. All right, I'm gonna go ahead and end it. We've got about 15% saying yes. However, the answer is actually no. So with these pink lines being the boundary conditions and this being the flow, we have quite a bit of ponding here with nowhere to leave the system. So we would not want to see this because this is a falsely high depth and would give us a lot higher water surface elevation than would actually be there. And then next question. Looking at this image, is the geometry accurately representing the flow paths here? So the image is showing inundation within the mesh geometry overlaying the terrain. Okay, nice. Seems like about 80% of you have got this question right. And the answer is again, no. So if we look here and here, we can see in the terrain that the water wants to go in this direction, but we have what looks like in the terrain a high spot of potentially road here and a high spot of road along here. So flow is stopping here, and it's not able to actually get all the way through this channel. So this would be something we'd really want to flag if we're looking at a 2D model. This is a really great indication that they didn't add a structure here like they're supposed to, and they don't have a structure here like they're supposed to. And then last question, looking at this computation log output file, do we think the model is stable? Ooh, very split on this one, keeping it right at about 50-50. All right, I'm gonna stop it there, but actually 57% of you have got this one slightly incorrect. So this actually is a yes. Our percent error here is 0.07093, and that indicates it is a stable model. So important to note with the computation log output file and the runtime messages, this is actually given in the percent value already. So it doesn't need to kind of move that decimal point over 2. So we would say this is good to go. And then I will hand it over for some closing remarks. Thank you all.
Hey, I think the last question 9, maybe we showed a wrong one. I think we have a time. Maybe Keith, you want to repost or repoll the question 9?
There's not the right question's not in there, so.
Oh, okay.
Oh, okay. Apologies, everyone. I did not know that.
Everybody get a free pass. So with that, I think with the closing remarks, I wanted to say thank you everybody for spending some time with us, and hopefully you are able to get some basic understandings. If you already know the basics, especially from the 2D modeling, you learn something, either the differences between the 1D and 2D modeling from a no-rise floodway perspective, or if you already familiar with all of these, but then you wanted to know more about the technical review or an administrative review. Hopefully this webinar helped you look at the step-by-step process and use some of the handouts in future to apply for it or use it for your benefit. So hopefully we answered some of your questions, or maybe have more questions, so which is a good thing. That means you learn something and then you also have some additional questions. So with that, myself and Lauren would thanks for all of you to spend some time with us, and hope you got some technical background about the 2D modeling, especially for the floodway no rise. So with that, I will hand it over to Shilpa to close it.
Thank you. Thank you, Sarah. Thank you for joining today's webinar. As I mentioned earlier, this webinar is being recorded, and the recording as well as the slide deck will be made available to the participants at a later date. With that, thank you for joining today's webinar, and have a good rest of your day.